Alright guys, welcome back. In the last video we have seen how we can bypass the certificate pinning which is based on a hash. In this video right now we take a look at the second option, certificate pinning based on a whole certificate. And for me, to be honest, this is way more easy. So this is like having a pony under the Christmas tree. So therefore let's have a look into this. Okay, so let's have a look into this one. I have already downloaded it and it's over here. Download certificate pinning _ cert. I copy this and we go into apps and we create a new directory. Certificate pinning _ cert. Alright, let's install this application. Keep this in foreground. Yes. adb install certificate pinning _ cert. Yeah, so I have provided the same package name to this one over here as the last one. So both certificate pinning _ cert and hash have the same package name, and they also are both signed with the same key. Therefore we have overwritten the existing version. That's why we have now this amazing purple logo over here. And so this doesn't matter at all, we have just overwritten the old one. Okay? Alrighty, so now let's open this one. And here we can see it's making directly a request to our RP endpoint, and yeah, it's the same text, and we also see this successful at the end. We also have a very nice layout over here, do we? Absolutely. So we also got this button. This means we can trigger those requests, successful and so on. Okay, the app is working regularly. This means if we now encounter errors after setting up our man-in-the-middle attack, this might be related to our man-in-the-middle attack. And let's have a look. First, let's run the Burp Suite. And therefore, we have to go into Tools and Burp Suite, and then we run the Burp Suite community. Let's close them. Click Next. Use Burp Defaults. Okay, here we have now the Burp Suite. We can close this one. Then within Proxy Options, we added this interface, and we go into specific 10.42.01. and we enable invisible proxy. Alright, this looks good right now. So let's establish our IP table rules. Therefore, we are opening a new root shell. Okay. And now we want to create a new IP table rule. Maybe let's first print them out. Nothing in there so far. Okay. Now IP tables -t nut. Then we want to append a new pre-routing rule. Protocol is TCP, destination port is 80, and we want to change the destination address to destination 10.42.01.80.80. And this also for HTTPS. Okay. And we can see error. Do we have an attacker? So suddenly I hit the button or the request got triggered again. Not sure what's the reason for this one. But let's see, if we hit this button once again, yes, within the dashboard we got an error, TLS failed negotiate a TLS connection for example.com, our certificate is unknown. Alright, this application seems to pin a certificate. It's not working anymore. Let's have a look into this, let's reverse engineer how this is being done. Alrighty, so let's close them, then we go into this directory, and this time I'm using JDX again. JDX GUI. So the application is being decompiled. And there we have it. And our first look is into the Android manifest. And there we go. We've got internet permission, of course. We only got one activity. And let's see. Do we have network security config? Yes, we have. Whoops, sorry. And there we have it. It's again within the XML directory of this application. So yeah, we can look it up here. Under Resources, XML, we have this config file. And this one has now a trust anchor regarding to a certificate. And this is within the raw directory and it's named server. So let's look in the raw. There we have it, server DER. So that's the binary format of this certificate. And we can see it's regarding to example.org. Nice. This looks very promising right now. So how is this certificate being checked in the application code? Therefore, let's have a look into the main activity. This one. We also can see certificate pinner helper. Sounds promising. So within the main activity, we've got our basic layout. Then we've got our inherited class, our subclass. And this one is doing something into background, certificate pinner helper. Okay, this one is calling this one over here. And here we're providing a parameter, some context, a client. And then let's see, we are opening this URL, example.com. Okay, and everything happens afterwards. So our certificate pinning, it seems to be related in this class over here. So let's have a look into this one. Okay, so here we are now at the certificate pinner helper, and let's have a look into this one. In this line, that's the constructor, we are creating a new X509 Trust Manager. A Trust Manager is simply just an instance that is managing our certificates. So that's a good point over here. Let's see, this one is being initialized with this function. And this one has another function as parameter. So let's start over here. And this one is returning an input stream, and this input stream is related to our resources raw server. So this is our server DER file that's being returned in this input stream. Nice. This means if you replace the server DER file, this one gets loaded into this trust manager over here. Absolutely perfect. This means we do not have to bother about other stuff here. We simply only need to replace our server DER with the one of the Burp Suite. This should be all right now. If not, then we have to dig deeper into this. But for now, let's have a quick look, maybe. Okay, so this is just returning our certificate. Then we've got this trust manager for certificates. Okay, this one is finally returning our trust manager. This is our certificate as input. And here we can see this really good. And certificate factory get instance. So here we are generating a new certificate based on ours. Okay, if this one is being empty, then we are creating a new password and we are creating a new key store. All right. Otherwise, we move on with this one over here. Okay, so far it looks pretty good. Let's simply go for the approach replacing the server DER file, and then let's see if this works out. If not, then we have to go back into this once again. Alrighty? Okay. So therefore, let's close this one. Let's get into our apps directory and let's decompile this. APK tool D. All right, it's being decompiled. Okay, certificate pinning cert. Now within res, raw. All right. Okay, so now we are in certificate pinning cert, res in the raw directory. And here we are having the server DER certificate. If we double click this one, we can see, all right, this is the certificate that might be pinned. It's regarding to example.org, so we are pretty confident that this one is the certificate. Okay, so what we need to do is we simply get our Burp certificate in DER format, and then we replace them with this one over here. That's all. Let's go into the Burp Suite, proxy, options, import export, certificate DER format, and then select it over here, Burp DER, save, and now let's go into this directory, and we simply drag and drop it over here. All right. Let's verify this real quick. Yes, this is our Burp Suite certificate. It expires, has a pretty extensive date when it expires. All right. And now let's do the magic. So what we do right now is the following. We are deleting or we are renaming this one. Okay. And now we can delete it. And we rename this one over here. And that's all. So having a certificate file directly in this application, that's that's a pony under the Christmas tree. That's the easiest approach to go for. All right, the only thing we need to do is we need to adjust the network security config to generally trust the user certificate storage. We can find this information within the Android developer documentation. And this one over here. There we go. This is the text we need to apply to generally trust our Burp Suite certificate. So let's get into the network security config. This is within XML, this one over here. So let's edit it. Okay. I guess we only have copied out the base config. So you need this network security config tag at the beginning and at the end. All right, now let's simply build this application back again. APK tool B. Okay, then let's sign this application. First we need to zip align it, 4 bytes. Out APK. Okay, successful. And now we are using APK signer. Password change it. Alright. And let's uninstall this pretty awesome looking application first. Let's close this one all. Okay. So uninstall. And now let's install our version, out APK. Success. Opening the Burp Suite. Dashboard is still throwing some errors, but we do not care about them. All we care about is our application. This one. Let's opening this and let's see. Nice. So the interceptor over here, it's flashing. So there, here we can see the request. Let's forward this one. And we get error. Do we have an attacker once again? No, definitely not. Otherwise we wouldn't have seen this request. This application will definitely abort any connection before it sends out a request. If you take a look at the HTTP history, we can see again we've got the request and the response. So, oh yeah, it's regarded to HTTP 2. Let's have a look into the project options, HTTP, and yeah, it's within the default settings, so unfortunately let's keep it disabled. Alrighty, now let's apply our response rule that we can directly hack this application. So we go into options. Then this time I do it correct. So intercept server response at domain matches any. This should work. Okay, intercept is on, send request. That's the request. Here's the response. Hacked once again. I guess the title is not being displayed, so we need to put it in here. Hacked once again. Certificate pinning. So what? Forward. There we go. Hacked once again. Certificate pinning. So what? Nice. This is how to patch the certificate pinning approach based on a whole certificate. Easiest approach. Okay, last but not least, I would like to show you something over here. It might be the case that the developer does not store the certificate itself. Instead, the developer is using a whole key store which is being protected by a password. And even this would be absolutely no big deal for us. We could simply replace the whole trust store. How can we do this? We have already created our own trust store. This one is holding our certificate that's being used to sign our applications. And this one over here. So if you go back into this one, and here we have our own trust store, our key store. And for example, if you want to display these certificates in this key store, then yeah, we can do this as follow. We can use the key tool, and then we can say list the certificates in this key store, and we provide the key store, Android-app key store. Now we need to enter the correct password. And in case if you're entering a wrong password, in this one for example, then we get this error, key store password is incorrect. But if we are opening this with the correct password, in this case it's change it, then we can see now all the certificates that's being stored in here. We can see we have one with the alias name, alias_name, and one with Udemy. So all we need to do is we need to get our Burp Suite certificate into an own key store over here, this one, or creating a new one. And then we have to take a look into the application. Which password is being used to open this key store? In case no password, I guess you have to provide a password. Therefore, there will be something in here. Then we have to choose the same password for our key store, or we have to patch the password over here. So the approach is absolutely the same. Instead of replacing the burp DER, we are replacing the whole key store, this one over here. So we simply drag and drop this into the application directory, and then we apply this password, and we are good to go. Alright, so this is how you can deal with the certificate pinning. If you have some errors, trouble, questions, feel free to write me a message. I'm glad if I received this feedback, and yeah, we will figure out what's the problem for you, and yeah, we will try to patch it together. If you have the permission for this application to do so. Alrighty? Okay. In the next video, we will finish our certificate patching journey with a transition into our next topic. We will perform a runtime manipulation, so we will have our first introduction to Frida. Because there are some amazing frameworks out there like Objection, which is doing a runtime manipulation approach to get rid of certificate pinning. So there are some pre-patches regarding to core libraries like the OK HTTP3, where we can simply patch it away with just 2 or 3 lines of code. Alright? Okay, so feel free to play around with this one, and yeah, otherwise I'm looking forward to see you in the next video.